Hey guys, we're going to talk about axis quadrant determination in this video. First, the electrical axis. This is a method of determining the direction of the heart's electrical current flow. The normal heart current starts in the sinus node or the SA node, which is in the top right of the heart, and it travels down toward the left ventricle, which is the bottom left. So if we drew an arrow depicting this current flow, the arrow would point down into the left. In an abnormal heart rhythm, the current may travel in an unusual direction, so it may deviate from this. So that's important to know, and that's what we're talking about when we talk about axis quadrant determination. In a few moments, I will get into more detail about and explain how you should determine your axis quadrant. But there's causes of axis deviation. The normal variant, a normal variant, it may be normal for some individuals, but it also may have an abnormal axis. So what I mean by this is it may not exactly be normal. It's not the perfect picture, but it's normal for you. Moving forward, we're going to talk about a myocardial infarction. An infarction is dead tissue. Electrical current does not go through dead tissue. So when we talk about a myocardial infarction or ischemia, the electrical current may reroute itself. It may go around the tissue, but it will not go through the tissue. And now we're going to look at ventricular hypertrophy. Hypertrophy or hypertrophied is overgrown tissue which requires more current. So we talk about that enlargement of the muscle, that enlargement of the tissue. It takes more current. It requires more and a stronger current to send the electrical impulse through. So that itself could cause an axis deviation as well. Arrhythmias may cause an axis deviation. Arrhythmias that originate in the ventricle, they may start in the ventricle and they may run up to the atrium. So if it originates in the ventricle, it's not following the normal pathway, the normal conduction pathway that we've talked about in the past that starts in the SA node. With advanced pregnancy or obesity, this may push the heart upward. It may push the diaphragm, which shifts the heart upward. And this could cause a shift in the axis. So we could have axis deviation here. When we think about chronic lung disease or a pulmonary embolus, this could cause a rightward axis shift because it enlarges the right ventricle. Remember, the right ventricle pushes blood into the lungs, and if there's a problem in the lungs and it can't push blood into the lungs like it should, it may become enlarged, or the right ventricle may hypertrophy, and this could cause an axis deviation. Let's talk about a hemiblock. A hemiblock, again, we said is a block that causes impulses to travel in an alternate direction. A hemiblock is a block that happens in the left bundle branch, so it's another subsequent block that occurs off of the bundle branch block. Let's look at determining the axis of the quadrant. I would like for you to go to page 37 in your book and look at the hexiaxial diagram. I'm going to scroll down. This slide is a little more in detail than what page 37 depicts, but it's still the same. If you look, AVF represents this line here. It runs up and down. Lead 1 is represented by this line here that runs right to left. AVL is this line that runs here. So again, let's repeat. We have AVF that runs up and down. We have AVL that runs from here to here. We have AVR that goes from here to here. Then we have lead 1. We have lead 2. And we have lead 3. And all of these are labeled outside of here, and this is just like the hexiaxial diagram that you will see on page 37, but this slide just has more information as far as the degrees, the right side and the left side, and the indeterminate axis. And I'm going to go over that in more detail with you here in just a moment. I'm going to show you how to determine whether you have a left axis deviation, which happens from here to here, or a normal axis that happens from here to here, so it's this area, or a right axis deviation that happens in this area, or an indeterminate axis that happens in this area. But for now, I need you to remember your hexiaxial diagram and know that this represents lead 1, this represents lead 2, this represents lead 3, AVF, up and down, AVR, and AVL. Okay, so now we're going to pick up with figure 13.1, the axis, circle, and the quadrant. As I said before, you will find the hexiaxial diagram on page 37, and you can break that down. It just shows you which one of these leads are which. But we're now going to take this a step further. You're going to see the left axis deviation that is labeled here. The left axis deviation represents this piece of the pie from here around. So this would be left axis deviation. Anything occurring in this area would be left axis deviation. When we talk about the normal axis, we're going to look from lead 1 down to AVF. Anything in this region would be normal axis. Let's talk about right axis deviation. Right axis deviation is going to be represented from here over to here. So anything in this piece of the pie is going to be considered right axis deviation. And now we're going to talk about the indeterminate axis. That is going to be from here up to here. So anything represented in this area is going to be indeterminate axis. So I'm not sure how the book breaks this down for you to determine your axis quadrant, but I'm going to tell you my way, and it's always worked. When we look at the axis quadrant determination, the first thing that we have to look at is lead 1. We want to know if the lead 1 is a positive or negative deflection, and then we're going to compare lead AVF. We want to determine if lead AVF is positive or negative. These are the only two leads that you'll be using to determine the quadrant. So we're going to work off of lead 1, which is here, and we're going to work off AVF, which is here. So flipping over to this slide, the first one says, if QRS in 1 and AVF are both positive, then you have a normal axis between 0 and positive 90 degrees. So with that being said, I want to flip back and show you this. If the QRS in 1 and AVF are both positive, so let's first look at 1. How do we know, what do we do, where do we go to determine if lead 1 is positive? The easiest way that I know how to tell you this is in lead 1, we work off of the center. Okay, so in lead 1, anything that goes from the center over to the right is going to be positive. Anything, if lead 1 is negative, if you have a negatively deflected QRS, and we know it's negative, you're going to start from the center and you're going to work this way. So from the center to the right is positive. When we're looking at AVF, I don't start from the center. I start from either this side or this side. So in the AVF, if I were told the AVF had a negative deflection, I would start from the top and work down because that's negative. If I was told that the AVF were positive, I would start from the bottom and I would work up because that represents positive. So when I'm looking at the AVF and I'm using this diagram, I start on the outside of the AVF. If I'm working with the AVF, I either start from the bottom or the top. If I start from the bottom and move upward, that represents positive. If I start from the top and move downward, that represents negative. If I'm looking at lead 1, I always start in the middle. If I go to the right here, if I go in this direction, then that's positive. Or if I go back to this direction, that would be negative. So with that being said, this is how I break it down. If the QRS in 1 and AVF are both positive. Let's look at 1. It says 1 is positive, so I'm going to travel this way. And then I have an AVF that's positive. All right, so I've marked this line. This is my area. So I'm going to start with AVF. It says it's positive, so I'm going to work off of the bottom and I'm going to move upward. So where do we meet? We're going from here to here. So that gives us a normal axis. Now we're given a scenario where it says the QRS in 1 is negative and AVF is negative. So when I work off of 1, I work from the center. I'm traveling this way. So this is my line this way. So this represents negative 1. And then I know I have a negative AVF. Well, this line right here in the center represents the AVF, but if it's negative, I'm going to start from the bottom, from the top, and I'm going to travel down in a negative direction. So I'm going to start from the top and travel down. So when we meet, it tells me that this is our pi. So we're at an indeterminate axis. In 3, it says if the QRS in 1 is positive and AVF is negative, what do we have? So we're working off of 1. We're going to start in the center, and it's positive this way. And then AVF is negative. Well, I know I have to travel downward to be negative, so I'm going to start working off the top, and I'm going to travel down. This gives us a left axis deviation. If the QRS in 1 is negative and AVF is positive, so we're going to start in the middle of 1, because we know this is 1. We're going to start in the middle, travel to the left, so we know we're working from the middle to this way. And then the AVF is positive. We're going to start from the bottom because we have to travel up to be positive. So we're going to start from the bottom and travel up. This gives us a right axis deviation because we know this is our pi. So I'll try to explain that better in class, but I hope that helps you guys. A normal axis deviation is from 0 to positive 90. A left axis deviation is going to be from 0 to negative 90, which is up here, so 0 to negative 90. So that's going to be in this area. A right axis deviation is going to be from positive 90 to positive negative 180. So positive 90 to positive negative 180, so that's going to be here. And then the indeterminate axis is going to be from negative 90 to positive negative 180, which is in this area. We're going to work on some strips in class. Will help you determine. So I would like to scroll down to the next slide just to kind of give you an idea of everything we went over. This would show you lead 1 is positive. So we know we're going to travel from the center to the right to be positive. And AVF is positive. It's in an upward deflection, so you're going to travel from the bottom and move upward. So that gives you this section of the pi, which is a normal axis. Let's look over here to the left axial deviation, the left axis deviation. Lead 1 is positive. You're going to travel from the center to the right, and AVF is negative. So you're going to start from the bottom and travel down. So this shows you this area. And so on and so forth. And when you're given these questions, you may be told lead 1 is positive and AVF is negative or whatever it may be, but you also may be given a strip where you have to look at the different leads and see, okay, this is a positive QRS, this is a positive QRS, so that tells me lead 1 and AVF here are both positive. Or in this case, lead 1 is positive and AVF is negative. So you're going to be given scenarios where you have to decide yourself whether they're positive or negative by looking at the QRS. But anyway, I hope this helps, and I'll be posting another video to go over more of this. Thanks, and have a good day.